let's get going. Okay, so today's lesson is really just about old exam questions, and I've got a selection of questions which you're going to do now. So this first question, it starts off with you're given a histogram. And so what I want you to try and do, it says a computer store sells 70 different kinds of games. The histograms shows their prices and quantities within those prices. So what you see here is that there are 7 games between 50 and 100 Rand. Now, in this first question, they want you to basically work out the estimated mean or show what the mean price is. And that's what I want you to do now. Because you can do this on your calculator, but because it's for 3 marks, you generally would probably have to here show you're working. And then the second question is to comment on the spread of the data. So I want you to try and do that. If you've got any questions, you can raise your hand or ask me an audio question, but let's start by giving that one a go and see how it goes. Mm-hmm. So maybe like a tip would be when you think of the mean, you normally have to get the sum of all the values and divide by the number of items. That might be a nice. How would you do that calculation? Maybe someone can give us a tip. What's the key thing we have to remember when working out the estimated mean? There's like one important idea. I'm wondering if anybody can help us in the chat. What's that key idea you need? It's almost like you don't have any values. You just have these intervals, and there needs to be some adaptation for that. Midpoint. Yes, Loretta. Yes, yes, yes. The midpoint is key. So for the first interval, when you've got values from 50 to 100, you're just going to use the midpoint value halfway between, which is going to be 75. Now, you could draw up a grouped data table. That's not wrong. But in the context of this, basically, you're going to have 7 items at 75 Rand. And then you're going to have 11 items at 125, and you just basically get the halfway point in these intervals. So if that's the case, what do we do to calculate our mean, our estimated mean? Also, normally with the mean, you need to know how many different items there are. So how many items are there in this data set? Maybe that could be helpful. Anybody know what the number over here is going to be? Well, if you've got 7 here and 11 here and 20 here in this interval, can't you just add these all up? Or you could say that you could look at the question and see there's a 70. Yeah. So this would be 7. So the top line is basically just going to say, well, how many values are there in the first interval? There's 7. So we go And each of those values is 75. So 75 times 7. And that deals with values in the second interval. And we use 1 times 11. So that's the second one. And then the third one is 20 values. And what value do we use? We use 175 times 20. And so we would.
Guys, I think we lost Mr. S there again. Please don't go anywhere. He will be back.
I switched away from Vodacom because Vodacom was not being my friend. Okay, so what do you get for your mean? Put in the chat what you guys are getting for your mean. So you carry on doing this, and I want to see what you get for your mean, or estimated mean. Or are there any questions? Is that making sense? Give me a thumbs up if my method is making sense to you for the estimated mean. Okay. So then I want to know, what are you getting for your final answer for the estimated mean? Okay, Leklocho. Here we go. Yeah. So 199.285. And so if you've showed that working out, if you've got that, what you then know is, okay, you're correct. If it was just one mark and they didn't give you the value in the question, you probably could have just used your calculator. But because of the fact that you are given 3 marks for this, you have to kind of show this sort of find the midpoints, multiply by the frequencies. Yeah. Okay, what about the spread of the data? So normally we ask you about this with box and whisker plots, but I'll give you a little bit of a hint. If you imagine that 70 is the data set, then halfway through the data set would be about 35 or 36. So probably halfway would be, somewhere around here, right? In this interval. Well, I mean, I suppose it would be that. Now, the top 50% of the data is spread out over here. The bottom 50% of the data is kind of in this direction. And think about how we spoke about box and whisker plots when we looked at the top and the bottom 50% of the data. See if that can help you to comment on the spread of the data. Maybe I'll use the highlighter. Like, if there's 70 items in total, the top 50% looks like it's spread out over that range. The bottom 50% feels like it's spread out in this range. So how would you comment on the spread of this data set? Even though it's not a box and whisker, it's a histogram, you know that the median will be about halfway through, so about 35, position 36, which is going to have to be kind of where that blue squiggly line is. Loretta has given an answer. Who agrees with her? Let's have a look. Yes. You guys are all correct. This data set is skewed to the right, or positively skewed, because the top 50% is kind of more spread out than the bottom 50%. And you can see this once you have an idea of where the median is. Okay. Any questions or comments on that before I move on? Okay, let's move on then. I like what I'm seeing there. Okay, I want you to try and do this question. I want you to try and do A, B, and C by yourself. Off we go. And you can put the answers in the chat. See how Stephanie, Loretta, I see the answers are coming through. Inam, I see your answer there. So that's definitely in common to both. That's definitely in common to both. And then the other one's not so much. Okay. So yeah, this would be the min and Q1 would be in common based on what you can see there. What about the second question? What about the second question? So Mason has an answer in there. I'm quite interested about your reasons for I agree it's set A. So set A is definitely the one that is symmetrical. So no problems there. What would you guys give for a reason? Does somebody want to maybe like give an audio comment on that? Oh, Loretta, you're brilliant. So Loretta said, so basically the way I would say it is very similar to what Loretta is saying, is the lower 50% of the data is just as spread out as the top 50%, or the 50% below the median is as spread out as the 50% above. So I wouldn't say equals, Loretta, I would just say as spread out, because that would probably be a slightly better word, but the general idea there is perfect. And then, okay, so I've answered B, so it's going to be A. And the reason is the lower 50% of the data is just as spread out as the top 50%, or it's symmetrical. What about C? Is the data skewed? Is the other data skewed left or right? State your reason. Okay, yeah. So the top 50% of data is much more spread out than the bottom 50%. Oh, let me use a different color just to, otherwise, what's the point? And so the bottom, so because of that, the data is skewed to the right. And the reason is, yeah, you can just say here, the top 50% above the median is more spread out than the 50% below the median. Or you could also say, I see some, Loretta said the uppermost quartile, you're right. So if you look at the top, or the 25% of data above the median, so this is the 25% of data above the median, it is more spread out than the 25% below the median. So that would also be acceptable too. And you can also see that the tail on the right-hand side is longer than the tail on the left-hand. Generally, I go with the top 50% and the bottom 50%, unless the question is asking, or if they look about the same, then I would look at the quartiles as well. Okay, give me a thumbs up if you're following, thumbs down if you find going a bit fast. Just want to do a quick check. I like what I'm seeing in the chat. Let's keep on rolling. Okay, here is a question which is different. This is a group data question. And so to start this, let's make this a little bit smaller. So you are given a medical aid scheme needs to, on the number of times people visit a doctor in a year. And so what this frequency table is saying is 32 people visit the doctor between 0 and 4 times a year. 71 people visit the doctor between 5 and 9, and so on. So first of all, what is the median class for the above distribution? Let's try and do that first. How do we find the median class when dealing with grouped data? This data is horizontal, not vertical, but It's essentially a grouped data table. Which one do you think it is? I suppose knowing the number of people is probably not a bad idea involved. So I was thinking, in order to get the total, there's two ways of doing it. The one is to add up the frequency column, or because you've got the ogive, you could look at the top of the ogive. So n in this question is 150. Now, to find the median, we normally have to find the position of the median, like how far is it? So remember, we want the median class. So we want one of these things here. So position Q2 . So which interval is going to include the 75th position is basically what we're asking. Okay? Which interval will include the 75th? Basically, if we were going from the bottom and we were going up, the interval that includes the 75th item cumulatively will be the median interval. So which one is that? Yeah. So you can see it can't be the first one because it's only got up to 32. When you add 71, you get all the way up to 100. So clearly you've gone past 75. And so the median interval is just going to be the 5 to 9 visits a year. Yeah, 5 to 9 visits. Yeah. Awesome. Okay. Well, now using that same idea, we're going to use the ogive. Okay, so we've got this ogive. It's showing visits along the bottom. So visits to the doctor along the bottom of the x-axis. And then we've got the cumulative frequency, because that's always what we have in ogives. Okay, so we've got that. And we know that the total will be 150. That's fine. You need to get me an estimated value for, and it says, use the graph to estimate the median, lower and upper quartiles for the given data and round off to the nearest integer. So I want to give you some time now to get me an estimate for Q1, Q2, and Q3 using what knowledge you've used in previous lessons. So. And you can use the graph. Let's see what you guys can do. Or if you've got a question, just raise your hand and we can talk about it. We already worked out that one. Secondly. What's this one? Okay, so I've got these positions, but I still need to get a value for these positions. So how would I do that? 37.75. $113. Sorry, my handwriting is not perfect on the small screen, but basically I went and found the positions of where these things are on the cumulative frequency vertical column, and then I traced them across to the horizontal visits. And what values are you getting? Remember, you're rounding off to the nearest integer. So we're rounding off to the nearest integer. What are you guys getting for Q1, Q2, and Q3? Let me know in the chat. So I see you guys are including decimals. That's awesome. In this particular thing, it says round to the nearest integer. So I think you could just go to the nearest integer to which one you're getting. And so the values that I would get based on what I'm seeing on the graph, let me choose a different color. I think Q1 would be 4. It looks closest to 4 to me. And then Q2 would be closest to 6. Because if I look here, and then Q3 would be closest to 10. And those would be my estimated values. So, you know, like 25%, well, yeah, that 25% of people would go to the doctor 4 times a year or less. Half of people would go 6 times or less, and so on, using this idea. Are there any questions about that? We're going to add a sort of higher order question now. So before I do that, I just want to check. Are you thumbs up if you agree with my 4, 6, and 10? And you see where I was going with that. Okay. So here's another part of the question. Okay, I've lost 1, 2 of you. So look there. Okay, so let's consider this statement. Consider the statement. Oh, what's going on here? Consider the statement. At least 40% of the people surveyed visited the doctor more than 10 times that year. Is the statement valid? Justify your answer with working. So I want to know from you guys, if you look at this drawing, we've just worked it out, and we've got this graph. Is the statement valid? Is it not? And if you want to come online to explain yourself, maybe that's also a good way to do it, or put it in the chat. Is the statement true based on what you see of this question? We've calculated Q1, Q2, and Q3. So for example, here is Q2, which we said was approximately 6. Now, more than at least 40% of the people surveyed visited the doctor more than 10 times a year. Well, where would I would tend to look at the 10 times a year thing and the more. So do you agree with that statement? Let's have a look. We can even get rid of some of the stuff over here and just focus. Kitty Bonner says no. Who agrees? Who disagrees with that? So the people who visit the doctor 10 times a year or less would be up here, right? So 100, and if you look at the ogive, 110 people visit the doctor 10 times or less. That means that only 40 people, so 110 visit 10 times less, because it goes all the way up to 150, only 40 people, so only these bits over here, visit the doctor more than 10 times a year. Now, it says, so I think this is invalid. It's not valid because if you think about the fraction 40 as a fraction of 150, what is that? So 40 out of 150. So let me, 40 divided by 150 times 100 is 26, is equal to 0.26 or 26%. So only 26% of the people visit the doctor more than 10 times a year. The statement said at least 40% of the people visit the doctor more than 10 times a year, so it must be false. So that was a much higher order question where you had to go and actually interpret the graph. I do think that I'm not going to linger on this for too long, but I just did want to show you a slightly harder question like that. Okay. Cool. What I want now is I want everyone on their feet. I want you to turn on your cameras and we are going to stretch it out. All right. Because our bodies have been thinking and working hard. And just do your favorite stretch to release some of that tension in your body after all that hard thinking.
Come on, guys, give your mind a break.
Come
Switch on
on.
those cameras so we can see you. Do your best stretch.
There we go. Oh, I feel so good. So Kekleko was asked, how would I put it into words? So Kekleko, I would first start by saying, according to the ogive, that 110 people visited the doctor 10 times or less. And then I would talk about the 40 that are left that visited for more. And then I would just do the simple calculation, the 40 over 150, 26% part. That's what I would put something around that. It doesn't have to be exactly the same as mine, but something to that sort of effect, because the 26% shows that the 40% is too big a number. All right, have you all had a bit of a stretch? Oh, I feel like I'm the one getting the best stretch in the house, but who knows? Okay, let's have a brain break. I want you guys to work out the mathematical word that is made up from those letters. So, what mathematical word could you make from those letters? I'll give you a little hint. What, Inam? What? How did you get that?
Well done, Inam.
Isimpiwe?
So quick.
Yo. So the correct first one is estimate. So estimate. Wow. That was kind of impressive. Not gonna lie. Okay, here's a second one. Can you figure out the mathematical word for that one? No, hold on. What is going on here? How did you get that so fast?
That was so quick.
Are you guys like anagram champions? Do you have like an anagram like training squad at your school? Tell us how did you get that so far? Wow. So the answer is kilometer. And you can see Kilometre. Wow. Tanaka, I don't know how you got that. Well done. Okay, sure. Did you see the earlier class? I'm wondering if, did you guys see these come? Be honest. Did you see this earlier, or did you get that on just in your head? If you did, wow, that is incredible. Okay, let's go back for the second half of the lesson. Last one. Oh, you want another one? Okay, let's see if I can find another one for you quickly. I've got one on standby here. I also feel like another one. I feel like we've earned another one. Where did I put this? Grab one. This is a tough one, but whatever. I'll give it to you guys. Can you get the mathematical word for that one? No, Muzi, how did you get that so fast?
Wow.
What?
I'm sitting here still trying to figure it out.
I feel like my brain is just clearly not, well, I don't know. Yeah,
Wow,
it's definitely
guys,
gone.
you guys are amazing.
Yo. This is like, yeah, it takes me a lot longer to do those. So, Muzi, you're quite right. It is decagon, which is a polygon with 10 sides, if I remember correctly. Okay, wow. All right, don't challenge you guys in this thing. Wow. Okay, let's move on to some more questions here. So what I want to do is I just want to do these two questions here. So we have I want you to start by calculating the value of y in this data set if you know that the mean is 41. So go ahead and do 1.2.1, see what you get. What value of y do you get? Siavuya, I see you have an answer. So I would start by adding up all of these things. What do you guys get if you add up all the yellow things except y? Yeah, 439, exactly. So you have 439 plus y, and then when you work out the mean, you divide by 13. So now what do we need to do? What's the last little bit we need to do to get our answer? We have to do something about this mean, because we're trying to find out what this y is. What do we need to do? Okay, a couple of people are saying 94, which I think you're on the right track there. So in the question, they tell us the mean for the data is 41. And so what we're going to do is we replace the mean with 41, and we then get this thing going on. And then we bring the 13 across. So we get 41 times 13 is 43 plus y. And then we would just subtract. So we go 41 times 13 minus 439. And we should get y is 94. Yeah, y is 94 for this. And in the next question, they do say y is 94. So that's good. I want you now to calculate the standard deviation of the data set. You're obviously going to have to use your calculators for that. And so the next step is to calculate the standard deviation of the data set. Okay, so remember with the data set, you have to include 94 here. So you have to include the 94, which is the value y. So remember, when you're working out the standard deviation, you go mode 2, and then you go into stat, and then you enter your data, which would be 5, 8, 10, and so on. Then you go mode stat, and then I think it's 4, and then, okay. See, I see a lot of students are getting 30.94, so let me check my answer sheet. And you should be getting, yeah, 30.94. I'm going to leave 1.2.3 for now because I think there's some better questions we can get to. But again, just give me a thumbs up if you were okay on that question, you know how to do the standard deviation. Thumbs down if you feel like we've left you behind, or I don't know, something to that effect. Just to get a feel for what's going on in the class. Okay. Cool. Let's move on to another one. So I want you to please answer these. Let's see if I can squeeze this in a little bit more. So that can come down in size and that can come down. Okay, so here are some questions and I will call them questions A, B, C, and D to make it easier. Off we go. See if you can answer the questions. Cool. Yep. I see some answers coming through. That's great. Okay, I agree. The first one, supermarket A, we have 35 as the biggest value and 10, wait, we should be looking at supermarket A, yeah, and 10 as the lowest value. Oh, but that's not, sorry, that's the range. I want the interquartile range. So the interquartile range, the 30 and the 20, and so the answer would be 10 because it's 30 minus 20. Describe the skewness of supermarket A. So what is the skewness of the top one? So I see the bottom 50% is there, the top 50% is there. It looks to me like it's negatively skewed. And if you need a reason, you can just say the bottom 50% is more spread out than the top 50%. Skewed to the left is also the same thing. Yeah. Perfect. Looking good, guys. Calculate the range of the data for supermarket B. So supermarket B, now I must be careful. I want the min and the max because it's the range. So we've got 35 up here and we've got 6 down here. So the range should be 35 minus 6, which is 29. Okay. And I like what I'm seeing in the chat. 29 is looking good. So during the 2-week period, which supermarket receives 25 or more deliveries per day on more days? Explain your answer. So, first of all, which of the two do you think receives more deliveries of 25 or more per day? And then what is your answer? What proof or what evidence can you extract from the drawing? So look at the scales and the values that are included. And then go from there. So we're looking for the one that experiences, let's go over the question again. During the 2-week period, so this 2-week period is being shown on this box and whisker, which supermarket receives 25 or more deliveries per day on more days? Well, let's look at the medians. Let's start by looking at the medians. So here's the median of here, that's at 26. And here's the median of supermarket B, which is that. The number of deliveries trucks make to neighboring supermarkets in a 2-week period. So 50% of supermarket A's delivery truck would be, it looks to me over here. No, okay, but what we're trying to do is which supermarket receives 25 or more deliveries. So this is what I want to say. 50% of the deliveries, okay, are going to be, so basically 50% of the deliveries are going to be more than 26. In this case, 50% of the deliveries are going to be more than 20. So I hope, think about that. Which supermarket receives 25 or more deliveries per day on more days? So I would say that the answer should be A. Yes, because you can imagine, like, what's the biggest day? So if we look at supermarket A, on one of the days, you get 35 deliveries in a day. But even the top 50% of the data is still going to be above 26. And then even some of the bottom 50% is still above 25 deliveries a day. Whereas if I look at supermarket B, then only, basically it's just lower down here. So the answer will be supermarket A. And probably the easiest way to describe that is just to say, look, the median is higher in the median in supermarket A is above 25, whereas the median in supermarket B is below 25. And so you can see that supermarket A would clearly be receiving more deliveries of 25 or more a day. So I would just look at the median. Yeah. Cool. That was a bit of a tougher question. Okay, so again, we were looking, what was the key in doing that? I think the key was just looking for the number 25, really. Because once you found the number 25 over here and the number 25 over here, you could kind of see that there's just more data above 25 in supermarket A. Okay, let's try one more question. We've done a question like that already. Let's do, don't want to do that one. Let's do something else. Let's do this one. Let's do this one. Okay, let's finish with this one today. So it says, the 2012 Olympic Games were held in London. They were, I remember them actually, they were very cool. The average daily temperature in degrees Celsius was recorded for the duration of the games, and a cumulative frequency graph is shown. So you have our cumulative frequency on the vertical, and we have the average daily temperature on the horizontal. How many days, over how many days was the 2012 Summer Olympic Games held? So if I look at my graph for the number of items, I'm probably going to go up here. 25, 26, 27, 28. Yep. So there's 28 days in total. Okay. Oh, my light just went out. Sorry, guys. My bulb just, anyway. Okay. Estimate the percentage of days that the average daily temperature was 24 degrees Celsius or less. Correct to 2 decimal places. So I want to give you a chance to think about this. I don't want to steal your fun, but estimate the percentage of days that the average daily temperature was 24 degrees or less. I'll give you a little bit of time and then I'll comment. I would go find 24. What do you guys think? So we want to know what percentage of days were below a temperature. We know the total number of days was 28. And then we know that how are we going to work out how many days were 24 degrees or less? Well, if we follow the ogive, we go from 24 and we go to the vertical, we get 13. And so then I've run out of light here, but 13, I'll use 13 divided by 28. And we should get 46, about 46.4%. Now, there might be some variation if you got a 12 instead of a 13, but 46.4% of approximately 46.4. No. Okay, guys, I'm actually going to call it there.